Now let us look into the measurement of friction power in an IC engine. Okay, the frictional power of an engine can be determined by any of the following methods. That is Willans line method used for CI engine, that is diesel engines. Second is motoring test, and third is the Morse test. The Morse test, what we have seen in the past, is similar for multi-cylinder engine. The test is common. Now the Willans line method. At higher speeds, the friction generated due to the reciprocating parts is more, and hence the power loss due to friction effects also increases. So the friction is a function of speed, okay, and definitely when the speed increases, friction increases. Williams line method, also known as the fuel rate extrapolation method, is used to determine the friction power of an IC engine. In this method, under constant engine speed, please understand this friction when you are trying to find out frictional power, the engine speed should be constant, fixed. Okay, the load is reduced in increments and the corresponding brake power and the gross fuel consumption readings are recorded. A graph of the fuel consumption on y-axis versus the brake power on x-axis is then plotted. Now you can see here, this is the Willans line method, this is the brake power, and this is the fuel consumption. So these are the points 1, 2, 3, 4, 5, 6. So we suppose we started like this at uh, this power, say 100% rated power, then 80%, 70%, 60%, 50. So we will draw this. Okay, then we will get the graph like this. Okay, this is y-axis is the fuel consumption and x-axis is the brake power. Then we see that when at zero brake power also there is some amount of fuel consumption, that is O to OM. So when you extrapolate this line, then you will find that OL, this is the power loss. This is known as the called as the friction power. Okay, we'll just go through that. The graph is extrapolated or extended back to cut the BP x-axis at L as shown in the figure. The reading OL is taken as a power loss or the friction loss of the engine at that particular speed. The fuel consumption is zero at zero brake power is shown by the line OM. As shown in the figure, the most of the power range in the relation between the fuel consumption and the brake power is linear, and when the speed of the engine is held constant, and this permits extrapolation. The one thing is if the graph is linear, and second, the speed of the engine is held constant, hence this permits the extrapolation or extending of the graph. Further, when the engine does not develop any power, that is brake power is zero, the engine still consumes a certain amount of fuel. This energy in the fuel would have been spent in overcoming the friction. Hence, the extrapolated negative intercept of the horizontal axis will be the work representing the combined losses due to friction, pumping, and as a whole is termed as frictional loss of the engine. This method of measuring friction power will hold good only for a particular speed, and is applicable mainly to the CI engines. So friction powers are found out for some particular speed, because the friction power at say 5000 rpm will not be the same friction power at 10,000 rpm. So this is for a particular speed only. Okay, and this is the Williams line method. Once again we will see the graph. Please plot the graph. I have seen one girl, that poor girl in exam, instead of plotting it here, cutting it OM here, she has started the graph from here only, and then she failed in the exam. Okay, I don't want to take her name. This is very bad. So you should understand that zero power also there is some amount of fuel, zero brake power also some amount of fuel is consumed, that is OM. And when we extend, then this OL, this is the power loss. We can call it as frictional power. Okay, thank you.